Greetings, everyone. We're going to take a look at our next lesson in this video. And this lesson is 7.4, Factored Form of a Quadratic Equation. What we're trying to accomplish in this lesson is to help you understand what the factors of a quadratic function do to help you understand a graph. What are they and how do they help us? So the vocabulary that we're going to look at is really just one word. We're going to make sure that you understand what factors are. So if I were to ask you what is the factor of a number, if I were to say what's the factor of 6, you might say, well, 2 and 3 are factors of 6. And so what you're doing is you're looking for numbers which multiply to equal another number. Smaller numbers like 2 and 3 multiply together to give me 6. So we say that 2 and 3 are factors of 6. So that should help you when I ask this next question, what is the factor of a quadratic function? Well, similarly, factors are small little polynomials like x plus 2 and x plus 3 that when I multiply them together, they give me a quadratic. And so we say that x plus 2 and x plus 3 are factors of this quadratic. They multiply together to give me the big quadratic. Now, the other question then that comes is, why is this of any use to me? Why am I interested at all in this factored form that I've shown you? The factored form, of course, looks like this, where I've got y is equal to, here's my x plus 2 and x plus 3, and I have some kind of number in front. This is just a number, so it could tell me that the graph opens up or down, or it's skinny or fat. Well, in order to understand it, we need to go back to just thinking about how we find x-intercepts for a minute. Here are x-intercepts on a graph. It's very easy. If I've got a graphing calculator handy, I can see them, can tell if there are no intercepts or two, and I can give a good estimate. But the problem with graphing is that if you do not have a graphing calculator in your hand, it's pretty hard to do this way. It's only a guessing game. So going back to that and realizing that that is an inadequate way to do it, let's go back and consider. When I look for x-intercepts, I know that y is equal to 0. So in order to understand what we're going to do next, you have to understand what's called the zero product theorem. And that says simply that if you have two numbers that are multiplied together and they equal 0, then one of them, either the a or the b or both of them, have to be 0 in order for that to happen. So now if you go back to this, and if I said to you, okay, we're going to try and find the x-intercepts, which means we're going to try and figure out when this is equal to a 0. Well, if that's equal to a 0, then I know that either this has to be a 0 or this has to be a 0. And when you turn that around, what you're finding is that x equal to -2 and x equal to -3 are the zeros of this function, or they are the x-intercepts. So in summary, when a quadratic equation is written in the factored form, and I'm just using random letters here, we can easily find the x-intercepts or the zeros of the function. Okay, so here's your first one. This is a graph. I would encourage you to stop and try and draw the graph yourself, picking out all the various parts, x-intercepts, y-intercepts, vertices, axis of symmetry, and see if you can eventually draw your graph. So x-intercepts, fairly easily. I look at this one and make it equal to 0, so I've got a +3 and a -1. Y-intercept, I put in x as a 0 and find that it's a -9. In order to find the vertex, I'm going to have to expand this and clean it up. So I multiply it out, clean it up, and multiply by 3. Then I use my formula. Vertex is -b over 2a, and I plug the numbers in, which gives me a 1. And I take the 1 and put it in the y, and I find that my y value is -12. So this allows me to draw a pretty accurate graph. Here's my vertex, 1 and -12. Here's my x-intercept, 3 and 0, and -1 and 0. My axis of symmetry, x equal to 1. And I just realized the one question I didn't answer here was what's the domain and what's the range? The domain would be x is an element of all real numbers, whereas the range is y is an element of the real numbers where y starts, so it's greater than or equal to -12. This next one. Now this one's interesting because if you look at it, you realize that its x-intercept is simply 2. And it doesn't seem to be anywhere else. And so if you try to picture that, it means it's going to be a graph that's just its vertex sitting right at 2, which makes it really easy to find your vertex. Your vertex is simply 2 and 0. And then we would want to figure out the y-intercept by plugging in a 0 for x, and so we get a 4. And this shows us what our graph looks like. Okay, now the other way around, I can ask you to give me an equation of a quadratic function and write the function in factored form. So what we're going to need is to see the x-intercepts. I have one at -1 and one at 3, and then we're going to need one other point. And I think that the y-intercept of 0 and 6 is probably the easiest to use. So first of all, if the x-intercepts are -1 and 3, then I can turn these into or back into their factors. X equal to -1, x plus 1 equals 0. So here you have it. And this one would be x minus 3. Now, if I know my y-intercept is 6, I know it goes through the point 0 and 6. And I plug that in, do a little bit of math, and find that my answer is -2. Okay, let's check it out. We've got an intercept at -1 and one at 2, and a y-intercept at -1. So using that information, we have our factored form. It's going through this, we figure out it's 1/2, and then we plunk it into the final equation. Again, stop the video whenever you need a chance to work and just catch up, make sure that you're doing the same work and that you've done it without any questions on your mind. All right, pause the video for a minute and take a look at this one. What we're looking at is a high school class that is selling t-shirts. They're trying to make some revenue. So what they've learned is that if they price their t-shirts at $15, they will sell about 300. But they've also learned that every time they increase the price and add on $2, they will sell 20 fewer t-shirts each month. So the more expensive they get, the less people who will buy it. So the question is, what should they charge to maximize their monthly revenues? Now, we're not going to be using an optimization problem here, all right? You didn't see any constraints, so it had to be less than, no more than. It didn't have any of that kind of language in it, so it's much more straightforward. So what we'll do is let x be the number of $2 increments, the number of amounts that we'll add to increase or decrease the value. So our original price was 15 and we sold 300. So these are the prices times the numbers sold. So if we add 2x, so $2, we're going to subtract or lose 20 customers. Put this in your calculator and find the maximum. Now, a couple of hints to do that. To use the graphing calculator well, you're going to need to adjust your window eventually, but start with the standard window, and then you'll see, I can tell I'm not seeing what I need to. So then choose a domain that makes sense. Maybe x min is 0 and x max is 20, and then try to graph again. Once you do that, you can also then choose the function zoom fit, and what it will do is it'll make sure that you see all of the graph between 0 and 20. That allows you to see the curve, and you can find your maximum by calculating the max, doing the left bound, the right bound, and the actual value. And then it gives you these values, 3.75 and 5,065.5. So the last step will be for us to sort out what the price will actually be. We know that the price is 15 plus 2x, so it's actually $22.50 that will give you the maximum profit. Okay, you should be ready to tackle your homework. So good luck, and remember, keep very close tabs on the stuff that doesn't make sense so that you bring it back to class.